In a certain factory turning out optical lenses, there is a small chance 1 by 500 for any one lens to be defective. The lenses are supplied in packets of 10. Use Poisson distribution to calculate the approximate number of packets containing no defective, one defective, two defective, and three defective lenses in a consignment of 20,000 packets. Now, let us understand this situation, what they have given and what they're asking us to solve. See, there is a factory which is manufacturing optical lenses. They are manufacturing lenses, and once the lenses are ready, they supply in a packet of 10. That means each packet consists of that. Single lens cannot be supplied because it takes a huge transportation cost. So they are packing them into the packet of 10. So all the lenses are, that means each 10 lenses are packed in one packet. So how many such packets are there with the company now? It's a consignment of 20,000 packets. They have a 20,000 packets of lenses, and each packet is consisting of 10 lenses out of which. Now, in that, they were found that that in production process anyways will be having a small error, small defective items will be there. So they have found out that there is a small chance of 1 by 500 for any one lens to be defective. That is their claim. 1 by 500 is nothing but, that means if you are manufacturing 500 lenses, the probability of getting one defective lens is that means probability of getting one defective out of 500 is 1 by 500. That means 499 out of 500 would be the perfect lenses. That is their estimation. Now, using Poisson distribution, they are asking us to find out number of packets containing 0 defective, 1 defective, 2 defective, 3 defective lenses. Means what? See, out of 20,000 packets, they are asking us to find out. Each packet is consisting of 10, that we are clear with. And now they are asking, out of 20,000 packets, how many number of packets are perfect lenses? That means there is no one defective also. Let us take an example. How do we find out? See, we know that in Poisson distribution, by using the formula, we can find out probability, but not the number of packets here. But they're asking us to find out of 20,000, how many packets are there. So let's take a small example. In a class, there are 60 students are there. In a class, there are 60 students are there. And here the ratio of boys and girls is 50%. Both boys are 50% and girls are also 50%. Then the strength of girls is 30, the strength of boys is also 30. How did we say that? Now I have multiplied total strength of the class, that is 60, into probability of getting boys, that is 50% of the boy, 50% of the strength of the class. So that means when I know the total value and probability, if I multiply these two values, then I'll get the number of students who are of boys and the number of students who are girls here. Similarly, out of 20,000 packets, they are asking me to find out how many number of packets are no defective. So to find out number of packets, what do? If I find out, anyways, I know the capital N value 20,000 packets. Now, if I find out probability of getting 0 defective, so I'll find out, so I'll multiply probability of getting 0 defectives into 20,000 packets. So I'll get the answer of number of packets containing no defective. Similarly, again, I'll find out the probability of getting one defective lens and I'll multiply with 20,000. Then I'll get the number of packets containing one defective lens. Similarly, for two defective and three defective lenses also. So that what is our main target in this question is, out of 20,000 packets, I have to find out how many number of packets are perfect packets and how many number of packets are having one defective lens, how many number of packets are having two defective lenses, and maximum of three defective lenses. So just to find out this one, first what do we need to find out? We should find out the probability of getting those values. First, let us write what are the values given. See here, n is equal to 20,000 packets. which is given to us. Now n, small n, that means each packet is consisting of how many lenses? Sample number of lenses is equal to 10 in each packet. Now, what is the proportion of getting a defective lens? That means probability of getting a success for us, right? So P is equal to 1 by 500 is given to us. So to find out this one, they themselves say that use Poisson distribution. Of course, though they say it or not, since they are saying is that it is of defective, we use Poisson distribution to find out the answer. Now, what is the probability function of Poisson distribution? That is P of x is equal to e power minus lambda into lambda power x sorry lambda power x whole divided by x factorial e power minus lambda into lambda power x by x factorial, where x is ranging from 0, 1, 2, 3 dot dot dot. That means it ranges up to infinite, out of which they are asking us to find out 0, 1, 2, 3. Now to substitute in this formula, first I need to see x is nothing but my number of successes. That means they are asking us to simply substitute what is x is equal to 0, 1, 2, 3. So to substitute x is equal to 0, 1, 2, 3, here first of all I need to know the value of lambda. So what is the formula of lambda here? Lambda is nothing but mean in Poisson distribution. So lambda is equal to NP. Now NP is nothing but n is equal to 10 into 1 by 500. That is equal to 0, 0 gets cancelled. Then it will become 1 by 50. That is equal to, we get the answer as 0.02. We get the answer as 0.02. So we got the answer of lambda. Let us substitute in the given expression as of now. So then this P of x will become e power minus 0.02 into 0.02 to the power of x by x factorial. Okay. Now, what is the first question they are asking us to find out? First one is no defective. No defective is nothing but x is equal to 0. Now, let's find that. P of x is equal to 0. That is equal to P of x is equal to, now e power minus 0.02 to the power of 0 whole divided by 0 factorial, out of which we know that now the value of e power minus 0.02, e power minus 0.02 is, so anyways, now 0.9801 into something to the power of 0, 0.02 to the power of 0 is 1, divided by 0 factorial is also 1. So finally 1 into 1 into 0.9801 is 0.9801. What is this? The probability of getting no defective. But we want number of packets containing 0 defective lenses is equal to capital N into P of 0. That is equal to 20,000 into what is P of 0? 0.9801. That is equal to, we get the answer as 19,602. That means out of 20,000 packets, 19,602 packets are perfectly packed packets. That means without a defective, there are all the lenses are perfect package, perfect lenses only. Now, similarly, we have to find out second one is one defective. One defective means now we have to substitute x is equal to 1. So therefore, p of x is equal to 1 implies e power minus 0.02 into 0.02 to the power of 1 into 1 factorial. That means anyways e power minus 0.02 is value is 0.9801 into 0.02 to the power of 1 is 0.02 into 1 factorial is also 1 again. Now, then 1 by multiplying these two values, we get 0.0196. So this is the probability of getting one defective lenses. Probability of getting one defective lenses. Now I have to find out number of packets containing one defective lens. One defective lens is nothing but capital N into P of 1. That means 20 into the total number of packets into 0.0196. By multiplying this value, we get 392.04 packets. 392.04. But the number of packets cannot be mentioned in decimals. So this value is approximately equals to 392 packets. That means out of 20,000, how many number of packets are containing one defective lenses? That is 392 packets. That is the conclusion of this problem. Similarly, we have to find out two more values, that is two defective lenses and three defective lenses. Let us do that. Now, we are moving on to the next case, that is two defective lenses. That means x is equal to 2 here. So P of x is equal to 2 implies e power 0 minus 0.02 into 0.02 to the power of 2 into 2 factorial. That means then what does this value become? Anyways, e power minus 0.02 becomes same 0.9801 into now 0.02 to the power of 2 becomes 4, and now divided by we have 2 factorial. 2 factorial is nothing but 2. Now by doing this calculation, we get the answer as 0.00019602. That means the probability of getting two defective lenses. This is only the probability. Now let us find out number of packets containing two defective lenses is capital N into P of 2, that is equal to that means total number of packets. While I multiply this value, the answer what we get is 3.92. 3.92. That means approximately equals to, because the number of packets cannot be equal to 3.9, right? So it is nearest value. That means 4 packets which are containing. That means out of 20,000 packets, there are only few. That means 4 packets are containing 2 defective lenses. That means out of 10, 2 are defective. Okay. Now let us move on to the last one, the similar case. Now we are going to solve this as P of x is equal to 3. Now P of x is equal to 3, then this becomes to the power of 3 and divided by 3 factorial. Then this numerator value will become 0.50 and something, and divided by 3 factorial means 3 into 2 is 6. 3 factorial value is 6. Then we get the answer as 0.130679. This is the answer. That means the probability of getting 3 defective lenses out of 20,000 packets is this value. So let us substitute. That means let us find out the number of packets now. So number of packets containing 3 defective lenses is n into p of 3 is equal to 20,000 into 130,679. Then we get the answer as 0.02613. That means 0.02. Though you convert it to the nearest value, we get 0 only. That means out of 20,000 packets, there are no packets which are having 3 defective lenses. There are no packets with 3 defective. That means they are having some number of packets with 1 defective lenses. How many packets? 19,602. 1 defective lens is 392, and the second one, 2 defective lens is 4. Now let us find out whether we have done the calculation right or wrong. See why? Because number of defectives with one lens are how many? 19,602 plus number of packets containing 1 defective is 392 plus 2 defective lenses is 4 is equal to, we have got 19,999 packets. We have got 19,999 packets. So now out of which we have got all different answers, and there might be the number of packets which might contain 4 defective lenses. That means the remaining 2 packets. We have got 0 defective, 1 defective, 2 defective, as well as 3 defective lenses also. Okay, so there might be the different. There are 2 packets which are left out as of now, because we have got out of 20,000, we have got 19,998 only. Okay, this is about how we get the values of number of packets. That means if probability is asked, simply we will substitute in p of x and we get the probability of that value. But if number of packets have been asked us to find out, first we have to find out of total. Once we know the proportion, probability is nothing but a fraction, that is nothing but a proportion. See, just now I told you that an example of out of 60 strength, proportion of boys and girls is 50-50%. So once you know the probability, once you know the total strength, I can find out the proportion of subparts. So here also we have done the same concept. That is how I have got all the values of the given problem.